Proteomics is a valuable tool for understanding the fundamental characteristics of an organism through the study of its proteins. This technique comprehends multiple steps. Start by anesthetizing the fish in a beaker with a little dose of phenoxyethanol, 500 ppm for fish with an average of 30 grams. Once the fish is turned upside down, remove the fish from the beaker, weight each animal and measure them. There are several types of samples that you can use for proteomics purposes. Biofluid samples such as mucus or plasma, which is obtained from blood centrifugation, and tissue samples. To collect this type of sample, open the fish with a sterilized scalpel, remove the visceral area, select the desirable organs and place them immediately in liquid nitrogen, properly identified. This procedure will be done with liver tissue, but other types of samples can be used. To extract the protein from the tissue, weight 50 mg of liver tissue from each sample and dissolve it in 500 microliters of Dage buffer, 5 microliters of protease inhibitor cocktail, and 2 microliters of EDTA 250 millimolar. After, add metal beads to the tubes and homogenize the samples with a tissue lyser for 2 cycles of 30 seconds at a frequency of 25 per second. Incubate the homogenized samples at 4 degrees for 30 minutes in constant rotation and centrifuge at 13 Gs for 15 minutes at 4 degrees to remove insoluble material. Then, collect the resulting supernatant and dilute 180 with the initial buffer. The protein concentration of the diluted samples can be determined with a Bradford assay. For this procedure, add 5 microliters of 7 curve standards and the 2 controls, blank and Dage, in triplicates to a 96 well microplate along with 5 microliters of each sample. Next, add 250 microliters of Bradford to the wells and read the absorbance at 595 nanometers. Finally, estimate the protein concentration and the volume of sample needed to collect 500 micrograms of protein to be used in the next step. The next step is to purify the extracts of non-protein contaminants using a cleanup kit. Briefly, add 300 microliters of the precipitating agent 1 to the protein sample, vortex and incubate on ice for 15 minutes. Add 300 microliters of precipitating agent 2 to the mixture and centrifuge the tubes with more than 12,000 Gs for 5 minutes to form a tight pellet and discard the supernatant. Add 40 microliters of wash reagent 1 on top of the pellet and centrifuge under the same conditions. After discarding the wash, add 25 microliters of ultra-pure water and vortex. After, add 1 ml of pre-chilled wash reagent 2 and 5 microliters of wash 2 additive and vortex the samples for 1 minute. Incubate the tubes at -20 degrees for 30 minutes and vortex every 10 minutes. Finally, centrifuge the tubes for 5 minutes at maximum speed and remove the supernatant. Air dry the pellet at room temperature. The resulting pellets are resuspended and the proteins digested into peptides by enzymes, such as trypsin. These peptides are analyzed through mass spectrometry techniques, such as nanoflow liquid chromatography tandem mass spectrometry. This technique separates, ionizes, and analyzes the peptides with high sensitivity. The resulting data are matched against protein databases for protein identification.